This video will generate the trend line and the equation of the Chebyshev second kind polynomial. And our definition of the Chebyshev second kind polynomial is the summation of times 1 minus x to the power k, where the value of a is the coefficient, which is negative 2 to the power k times factorial n plus k plus 1 all over factorial n minus k times factorial 2k plus 1. So we begin with the values of n and k, where the value of n is greater than 0, which is data validation, list of items from 1 to 10. That's 1, 2, and 10. So we have 10 values to choose from for the n. Our k will be from 0 to n. So this is equal to sequence of n plus 1, start one column starting from 0 incremented by 1. So if our n is 1, our value for k is 0 and 1. If n equals 2, our values of k is 0, 1, 2. And n equals 3, our value k is 0, 1, 2, and 3. Then we continue with the Taylor-Maclaurin series sum of the Chebyshev second kind polynomial, which is equal to array formula. Series sum 1 minus x. 1 minus x. And this is raised to the power k, so our k will start from 0, incremented by 1 until the maximum n. And the coefficient will be this range. So we'll work on the coefficients now. So here we have the trend line, which is also the Chebyshev second kind polynomial, trend line to the degree 10. And that's a trend line equation, and this is the trend line. So here we have the coefficients. We'll start with the denominator. So it is array formula. 1 over factorial. Start with the first one. N minus k. So n minus k. That's times, the second part is 2k plus 1. So 2 factorial again. 2 times k plus 1. That's the denominator part. If this is blank, this should be 0. So we have to correct that. So if k is blank, if k is blank or empty, then 0. Otherwise, calculate. So we're good. Let's try 10. Maximize. Now we can continue with the, but this is not actually 0. There's a value here. So let's try now the numerator part. Start with there are two parts, the factorial n plus k plus 1. So we have factorial n plus k plus 1, n plus k plus 1. That's the first part of the numerator. And we can continue with the other part. It's negative 2 to the power k. So that's minus 2 to the power k, and then multiply that to the factorial. So that's our 10. So we go back to n equals 1. So at n equals 1, our Chebyshev second kind polynomial y equals 2, 2x. Just 2x. This is 0. Everything else is 0. At, at n equals 2, our Chebyshev second kind polynomial is minus 1 or negative 1 plus 4x squared. The rest are 0. At n equals 3, our Chebyshev second kind polynomial y equals negative 4x plus 8x cubed, and that's it. Negative 4x plus 8x cubed. At n equals 4, our Chebyshev second kind polynomial y equals 1 plus neg or 1 minus 12x squared plus 16x to the fourth. At x to the fifth, y equals 6x minus 32x cubed plus 32x to the fifth, and that's it. At x to the sixth, y equals negative 1 plus 24x squared minus 80x to the fourth plus 64x to the sixth. At n equals 7, y equals minus 8x plus 80x cubed minus 192x to the fifth plus 128x to the seventh, and at n equals 8, y equals 1 minus 40x squared plus 240x to the fourth minus 448x to the sixth plus 256x to the eighth, and that's it. At n equals 9, the value for y is 10x minus 160x cubed plus 672x to the fifth minus 1024x to the seventh plus 512x to the ninth. At n equals 10, our value for y is minus 1 or negative 1 plus 60x squared minus 560x to the fourth plus 1792x to the sixth minus 2304x to the eighth plus 1024x to the 10th. So this completes the use of sequence, array formula, and factorial in generating the trend line and the polynomial of Chebyshev second kind